ठीक है, मैं लाइव पे क्लिक करता हूँ, मैं तुम्हें बताऊंगा जो हम लोग लाइव।
ओके ठीक है।
Yes, we are live now. You can start, Nitin. We are live.
Okay. So I can talk now?
Yes. You can see the
Okay.
comments in the. You can ask a student.
Okay, yes. It's
Here
starting
we see.
right now, I think.
Yeah.
Okay, so hi everyone. Please let me know in the comments if I am audible to you. You can say in the chat box if I am correctly audible to you, so we can start this session. Yes. Hello Rakesh. Okay, so I can see your chat. So can you tell me if I am audible? Okay. Yes, thank you. So now we can start this session onwards. So what we are going to do in this session, let me brief with you guys. So we are going to solve few questions that were asked in previous TCS NQT examination, especially for the TCS digital role, okay? And currently TCS has also announced one more role, that is TCS Prime, okay? So the question pattern is quite similar for both the roles, okay? Just the amount of question that you solve will be decided, or your performance in overall exam will be decided, that you will be getting either digital role or the prime role, okay? That we are going to discuss at the end of this video if you have any doubt in that portion. But for now, let me just share my screen first with you guys, okay? So you can say if my screen is correctly visible to you all. You can message me in the chat box. Okay, thank you. So is this question that I am sharing with you guys is visible to you? Okay, I can see. Okay, that's fine. So this is the question, okay, that were asked in TCS NQT examination, last year examination, 2023 examination that I got, okay. And since the question is, the screenshot of the question has been taken, so I converted it into the text document, so that will be correctly visible to you guys, okay. So let me read this question to you once and understand the problem statement to you. Then we are going for the solution part onwards, okay. So let's read this question. So the question says, Rocco is an island near Africa, okay. So in Africa, they say there is an island named as Rocco, and which is very prone to forest fire. Forest fire is such that it destroys the complete forest. Not a single tree is left. This island has been cursed by God, and the curse is that whenever a tree catches fire, it passes the fire to all its adjacent trees in all 8 directions: north, south, east, west, northeast, northwest, southeast, and southwest. Okay, and it is that the fire is spreading every minute in given manner, that is, every tree is passing fire to its adjacent trees. Suppose that the forest layout follows the tree, where T denotes the tree and W denotes the water. Okay, so there is an hypothetical story is been given to us, and in the same way TCS generally form their question. Okay, they generally tell you one story first. Okay, and in that story they hint something in that content only, and after that the problem statement will come where they want some solution on this story problem from you guys. Okay, so this story we have to look at this story very carefully. Okay, read this very carefully, because our all information is been given here only. So they say there is an island in Africa, and that island is very prone to forest fire. That means forest fire occurs there very gradually. And now you can say forest fire is such that it destroys complete forest. So when forest fires occur somewhere, so it will destroy the complete forest in itself. Now the questions comes, this island is being cursed, so they say something, some story like this. But the main part come here. So you can see when a tree catches a fire, whenever one tree catches its fire, then it will pass the fire to all its 8 adjacent direction. So you can see, if this is a tree, okay, if this is a tree, and if this tree catches some fire, so it will do what? It will pass this fire to all its adjacent trees, okay, adjacent direction trees. So what are all its adjacent direction? You can say this direction, this direction, this direction, this direction, and then these all 4 direction. So you can say these all 8 direction they will pass the fire to. So east, if you know the direction in the reasoning part, east, west, north, and south. Then you can say this at northeast, this at east, southeast, this at southwest, northwest. Okay, these all are the direction. They, if there any tree present in any of the 8 direction, they will catches fire automatically. So this is the phenomena that we have to note. Okay, because our questions is related to that only. Now you can see, and it is given that fire is spreading every minute. So in every minute, the fire is being spreading. Every tree will spread the fire to another tree every minute. Okay. Now the given manner. What is the given manner? This is the manner that it will spread the fire in all 8 directions. Okay. So are you getting it? Okay. I can see. Okay. Some comments will be coming. Yes. Okay. You can see this questions onwards. Okay. I will going to describe this question with you guys. You will understand it. No worries. Okay. Because now the understanding portion is not completed yet. Please wait till you will understand this question. I will understand every portion one by one significantly. Okay. So now you can see, now the main questions come. This is the story. We understood the story. Now we will come for the task that we have to do. Now what the task we have to do? So your task is that the given location of the first tree catches fire. Okay, we have been given a location of the first tree in that forest which catches the fire initially. Okay, and determine how long it would take for entire forest on fire. So we have to tell that how much time actually it's required for all the forest, all the trees in the forest to catches the fire. This is our task. Okay, we have been told, we have been given in the question itself the first tree location where it is been catching fire, and we have to tell that how much time is actually required for all over the forest to catch that fire. Okay, now you can see, you may assume that the layout of the forest is such that the whole forest will catch fire for sure, and that there will be at least one tree in the forest. Okay, so there's some easy portion will come. So this is a question. Okay, and after we will solve this question, we will change this question a bit, because same question will not be asked to you. But what companies might do, they will change this question a bit, and then this question is being asked multiple times with you guys. Okay, now you can see, so this question we have to assume one thing, that the layout of the forest is such that forest will burn always. Okay, so we do not have to worry now that is there any case where all the tree will not be burned, because it's stated in the problem that the layout will be given in such a way to us that the forest will burn out eventually. We just have to give them the actual time it will require to burn out all the forest. Okay, are you getting it? Okay, if anyone have any doubt, you can comment out in the chat box. Okay, now we will go for the next part. I hope you understand what the task we have to perform. Okay, now the input format. What is the input format? Now whenever you are solving any problem in the examination, especially in the TCS, because in TCS you have to note the compiler which you have been provided, there you have to write the code from the scratch only. Okay, because in some companies, in other companies, if you are giving some examination, then there might be the case there you do not have to write the main function by yourself. Okay, you just have been given a function, and there we have to write the logic for that problem statement. But here in the TCS, what happens in the previous years, that you have to write your code from the scratch, that you have to write everything from yourself only. So you have that practice. Okay, you have to have that practice to write the code from scratch. Now And to writing any code from scratch, the input format is very important for us because we have to take the input by ourselves only, okay, in the main function. So input will be how you can see the first line of the input is what? M and N. Now what is actually M and what is N? These are the two integers spatially separated, okay, and given the size of the forest in terms of the number of row and column respectively. That means M will represent the rows, okay, and N will represent the columns. That means it looks like it is a 2D matrix problem, okay. And let me tell you, from 4 to 5 years, if you analyze the pattern of TCS coding, then generally they are mostly preferring the question from 2D matrix. Okay, are you getting it? So this is again the question from same scenario. Now you can see the first input line is being covered. Now in the next line of the input, the two integer x and y again given to us, and here x and y is actually representing the coordinate of first tree that catches the fire. Okay, so in 2D matrix, if you have joined the TCS NQT paid course, okay, so let me once show you that course. Okay, so here you can see on my screen, we have launched for you guys a TCS NQT crash course, okay, where we 1,000 of recorded video is already been present. Okay, if let me show you 1,000 of recorded video in the content section you can get from this course only. And on the top of that, we are arranging a daily live classes on the way. Okay, in this course only we are arranging a daily live classes where I and more teachers, more 5 to 6 teachers that are very, you can see the schedule is being shared with you guys also in the YouTube channel community only. So you can see every day on the week, new live classes is being made for you guys where we have been discussing this thing in detail. Because you can see here in the YouTube, okay, in the YouTube platform, there are thousands of guys who are watching this video, okay. So it is difficult for us to focus on one by one and solve the problem of everyone individually. But in the live class, since we have a certain strength on which we are taking the live classes, so there we can give one-to-one mentorship for every student, okay? You can get the benefit of that. And the previous live classes that I have taken, we have explained this thing in detail. Just see, this is a problem in YouTube, okay? So I can see someone will saying it is an easy question. Okay, yes, I can understand. If you done this kind of question previously, then that might be an easy question for you guys. But you have to consider this exam is for everyone, and everyone is preparing and putting their full effort for this examination. So whenever we had teaching in any open source community, okay, then we have to teach everything from scratch. I will not come in the very first class of myself and starting teaching you the dynamic programming approach itself from the start only. Okay, so everything takes time because something is being easy for one or two guys, but we are considering whole community, so we have to take everything from the scratch only. I hope you are understanding this part from my side. Okay, now you can see, so you can check out that course as well because in 25 days I think your exam will happen. Okay, and the current scenarios that you will have to prepare a very good to crack an examination because you know what current scenario is going on for you guys. Okay, so now let's come to this portion. So here in the 2D matrix, what we are discussing, so in 2D array, okay, to access any position we need two coordinates, and there the two coordinates is being given to us as x and y. And I have told you this will be formalized. X will represent the coordinate of row, at which row actually the tree is located in that forest, and y will actually represent the column, in which column actually the tree is being located that catches the fire first. Okay, are you getting this? Now these are the first two lines. Okay, so first two line will look like m and n and x and y. Now on the bottom of that, now we have been given the structure of forest. So forest will be like what? So in forest structure will be m rows and n columns. That means if we take 3 cross 3, that means 3 row and 3 column, then it will be like the 3 rows in the forest and 3 columns in the forest. Okay, and the structure will be looking like this. So below this, the structure of the tree is being provided to us. Okay, so are you understand how actually the input is being given to us? Okay, if yes, then please comment down. And now you can see the next thing is the constraint. Now, after looking at the constraint, you will understand that at what is the actual time complexity that is being required to solve that problem. In the live classes or in the recorded videos that you can get in our NQT course, there I have made a separate video on time and space complexity, that how only by looking at the constraint you will be able to understand that which algorithm actually works and which algorithm will not works out there. Okay, since we have a limited time, so we will not go there in this lecture only. Now here in the constraint you can see the maximum size of M will be 20. That means there are maximum 20 rows are there, and minimum rows count is 3. Same for the N also. So minimum column in the forest will be 3 and maximum will be 20. Okay. Now I hope you are getting it. Now we can go for the sample input. Okay, so we have been given a sample input here. Since it is actually a screenshot of that problem, so we will not get the complete problem statement, so that we not get all the sample input. Okay, so we will make some few by ourselves only while we are solving this problem up in this video forward. Okay, you can see 3 cross 3. Okay, so 3 cross 3 will be what? M and N. So here actually 3 rows and 3 columns. Okay, so one thing is missing, X and Y. So let's say X and Y will be 1 and 2. Let's assume that. So X and Y, that means X will be the first row and second column of that matrix will be the first tree which catches the fire. Now we know that in 2D matrix indexing start from 0, but here the indexing will be 1 index. Okay, so we have to convert the 1 index. We are taking 1 index value. Okay, so 1 will means first row, but if we want to take out first row, or if we want to reach first row in our code, then that will start from 0, because 0 indexing is there in the array. I think you are already aware of these concepts. Okay, so that thing we should be handling, okay, in this video also. So I hope till now we have I am able to understood you the complete problem statement. If yes, then please comment down. Okay, and now we are moving with the solution of this, that how we are going to think the solution of this problem. Okay, so thinking is very much important. Now you can see, let's consider this example only. Let's consider this in broad way. Okay, so W, T, T. Now W represent water, T represent tree. Now this T, W, and here again W and T and T. Okay, let's consider this diagram here. Okay, so here from the start you can see we have been given, this is actually 3 cross 3 matrix. Okay, you are aware with this, because 3 row and 3 column are present here. Now the first index of the tree which catches the fire initially at the 0 time. Okay, so this is 1, 2. Now since this index is 0, 0, this index is 0, 1, this index is 0, 2. This has index 1, 0, 1, 1, 1, 2. And here you can see 2, 0, 2, 1 and 2, 2. Now if anyone comes and simply access that what is actually, let's say this has a name of mat. Okay, if we simply want to access matrix of X and Y, matrix of X and Y, then that would be what? You can simply say matrix of, go to first row and second column, then you will reach to this. Okay, but I have already told you this question has 1 indexing start with it, and our matrix that we have designed is 0 indexing. So we have to convert this was 1 indexing to the 0 indexing. So how we will convert? Just subtract 1 with that index of row and index of column, and you will get the 0th index row and column. So here the 1 index row and column will be 1 and 2. Okay, X and Y. Simply subtract -1 with both. Okay, you will get 0 and 1. So you will get the new value of X and Y, which is actually a 0 index. Okay, I hope you are getting it. Now you can see from here, so we will just have to reach to this index value. That means we have to reach, instead of this, we have to reach to matrix of 0, 1. Okay, are you aware with this? Now how this location is what? So we have to first go to 0th row. So it is actually 0th row, and in that 0th row, we have to go to the first column. This is the first column, because this is 0th column, this is first, this is second column. So this is first column. So we will reach to this tree first. Okay. So this tree will catch a fire at 0 time. Okay. At 0 time, this tree will catch fire. Now, what is the property? In the story, it is explained. Whenever a tree catches fire, it will passes the fire to all its 8 adjacent direction, and that will happen every minute. That means after every passing minute, the tree will spread its fire to all its adjacent directions tree. Okay. And what does mean? Waters means that the tree will not be transmitted on the water, because water do not catches the fire. Okay. So tree will only spread the fire in its A direction if there are any tree available there. Okay. Are you getting this? This is just a common sense. So here, for this tree, the 8 directions are respectively, he can spread the fire to this direction, he can spread the fire to this direction. Okay. He can spread the fire to this direction, he can spread the fire to this direction, he can to this direction and to this direction only. Now, if you observe here, let me zoom it out. Okay. Let me zoom it here. Okay. So you can see, if tree wants to spread its fire to this direction, here is water, so it will not catches fire. No worries. Now, if tree wants to spread its fire to this direction, okay, let me change the color. Okay, that will be fine. If tree wants to this direction, there is no tree present, nothing is present, so it cannot do in this direction also. In this direction also, there is nothing present. Here also, in this direction, there is nothing present. But this direction, you can see, in its east direction, it is actually east direction. So in the east direction, there is a tree present, and it will catches fire. Since this tree will catches fire in 0 second, so its adjacent tree will catches fire in 1 minute. Okay, in every minute, another tree will catches fire which is adjacent to it. Okay, are you getting it? Please comment down. Okay. Now you can see from here on, again for this also, this tree will catches fire. Okay, in 1 second, because it is adjacent to this tree. Again, other direction, there are no tree present to its other direction. So there are only 2 of its 8 direction the tree is present adjacent to it, and that will catches fire in 1 minute. Okay. Now, after this tree catches fire, now they will again spread its fire. So for this tree, you can see, if you consider all its 8 directions, there are no tree present in its 8 directions. So he cannot spread fire forward. Okay. He cannot spread fire further. He will burn down eventually, and that will be over. But for this tree, if you observe, for this tree, this direction, that is actually, this is east, and this is actually what you can say south. So southeast direction, actually, there is a tree present. Okay. In the southeast, adjacent to it, there is a tree present. So he will catches fire in 1 second. That means its adjacent will catches fire in 2 minutes. Sorry, I'm mistakenly saying seconds, but here the minute is given. So he will catches fire in 1 minute. That means its adjacent will catches fire in 2 minutes. And now there are no other trees present in all its other directions. So that will be eventually over for this tree. Now, when we come to this tree, now he is catching fire. So he will do what? He will again spread its fire to its adjacent 8 direction. And if we look forward to its adjacent 8 direction, so there are only one direction, that is east. A tree will be present, and that will eventually catches fire. Since it will catches fire in 2 minutes, so its adjacent tree will catches fire in 3 minutes. And after that, if you observe, there are no more tree present in this forest that is still happens to catch the fire. That means all the tree is now burning, and that will be done in how much minute? 3 minutes. Okay. So eventually, after 3 minutes of catching fire to this tree, the first tree, that is 0,1 tree, all the tree in the forest will catch fire. So are you getting this? Is this concept is clear with you? How actually this is being done? And you can see also the answer is also coming as 3. Okay. So I think this is clear with you guys. And if this is clear, then please comment down. Okay. That will be very much helpful for me to understand that you are getting the concept that I am teaching you or not. Okay. Now, how that will be done? How actually this will be done? We know the approach, how actually it is being doing on in the forest, but we have to write the code for it. Okay. How actually the code will be done? Now, for traversing, whenever the term comes that we have reached from one point to another point in a matrix, okay, then we will either go for BFS approach or DFS approach. Okay, I have taught all this in my TCS NQT course. You can, if you are not aware with this thing, you can go and enroll for that course and watch that course up there. Okay, that will be very much helpful for you. But if you understand this here on, the BFS technique, BFS means what? Breadth first search. Okay, we are searching for every tree in this matrix. Okay, and how we are searching? In the breadth-wise approach. You can see I am searching it in the breadth-wise approach. So we are going to use the BFS technique here in this problem to solve this problem very much easily. Okay, and now how actually this BFS will be implemented? Okay, even if you know the BFS, then if I change this question to some other part, then you have to think for that. Okay, and please wait for this video. I am going to change some of the content of this question also, and then we are going to solve that also. Okay, if something is being changed in this question, then also we are going to solve that. Okay, now let's understand this, that how actually this will be done here. So in BFS, how actually we are be doing? We are using a data structure named as Q. Okay, I think you are aware with this data structure Q. Now what actually Q is? Q is a data structure which is first in, first out. That means which comes in the queue first will go out from the queue first. That you should know. Okay. Now how we are implementing this queue to solve this kind of problem? What we are going to do? You can see from here. We are going to insert this position, the tree, initial tree position in the queue itself. Okay. Initial tree position in the queue. Let's say we are going to insert 0,1 in the queue. That means the position of the first tree that catches fire, and what is the time when it caught fire. So the first tree which the location we have been given already in the question will catches fire initially. That means at time 0 it will catches the fire. Are you getting this? Now what we are going to do now, we are going to check all its 8 direction, all the 8 direction of this index position, and see if there is any other tree present in the adjacent of these directions. If the tree is being present, and one thing we have to consider, that tree which we are now onto will not be burned already by someone else. What I am saying you, if you consider, let's say consider this example. When we are searching for this tree to burn its adjacent tree, so since this is adjacent to this, so this is again adjacent to this tree. So he will again go and burn to this? No, it is actually burning. From its only this is being burning. So now it will not go and burn this tree. It will burn the only unburned trees. So only unburned trees, that trees is not burned yet, will be burned only. Okay. That thing we also have to consider in this problem. So for that, we will again create one array. Okay. One array, and we can name it as a visited array. So what we can do, we can mark it as either true or false. Okay, we are going to understand you all this thing here in this class only. So we are going to, what we are needing, we are just getting it. So what we need to solve this problem? So first, we need a data structure name as Q. Then we need an array, okay, to mark the already burned tree. Okay, that thing we are needed. Okay, so we have to consider, or we have to search for the data structures like this, which will be helpful for us. Okay, so that we will get to know that which tree is already been burned or not. Okay, are you getting this? Now let's see it here. So these are the things that we require. Now how actually it is being done? So let me write the pseudo code for this first. Okay, let me erase this. Okay, thank you. I can see few of you are answering. Clear? Okay, very good. So now, how actually this is being done? So we have to take the input. The input we are taking in the compiler when we are coding it. Okay, the input thing is not that great. But how actually the logic is being written in the BFS part? So we have to check, we have to go and check for all its 8 adjacent direction. Okay. Now this thing you should know. If we are at index something like this, now how I will get all its 8 adjacent position? So let's consider one thing. Okay, so if we consider a matrix, okay, let me consider a matrix here, 3 cross 3 matrix. For this, okay, for this, the adjacents are this, the adjacent are this, the adjacent are this, the adjacent are this, this, and this, okay. Now, if I want to go, this is actually the index what? This is the index actually 1 comma 1. Okay, let me change the pen color. So it is actually 1 comma 1, okay. If I want to go to its east, I will reach 1 comma 2. That means I have to add what? In the row, I have to add 0. In the column, I have to add 1. Okay. Since in the same way, if I want to reach this position, so this position is actually 0 comma 2. So for that, I have to subtract 1 from my row and add 1 to my column to reach this. In the same way, if I want to reach here, this is position 0 comma 1. So subtract 1 from my row and add nothing to the column to reach this position. Okay. Similarly, this position will be gotten how? Subtract 1 from my row and subtract 1 from my column to minus 1 and minus 1. In the same way, I can get all the direction where I have to reach. So to get all its 8 direction, I have to subtract. Let's say if I want to see the go to the east direction. So for that, I have to add 0 to my row and add 1 to my column to reach that direction. So this is how actually we find all its direction. So to get all its direction, we have to get 8 pairs. Okay. So the 8 pair will be 0 comma 1. You can say 1 comma 0. Okay. 0 comma 1, 1 comma 0. 1 comma 1 will be also one thing. Okay. I am thinking of this. Anyone can say other direction. You can see minus 1 comma 1 will be also one thing. Other directions, if anyone can say, you can answer. Let me see the chat box if anyone is answering anything. Anyone is not answering? No worries. Okay. So let me write it again. So minus 1 comma 1, 1 comma 1, what I have written till now, and minus 1 comma minus 1. Okay, 0 comma 1 we have written. Then we have to write 0 comma minus 1 and minus 1 comma 0. Now if you can say 1, 2, 3, 4, 5, 6 and 7. Okay, one thing is missing. And let's see what is this. 0 comma 1 I have written. I have written 1 comma 0. Okay. Okay, minus 1 comma minus 1 I have written. Okay, one thing I have missed, that 1 comma minus 1. Okay. These are the all 8 direction. If we perform this operation, we will get all of its 8 adjacent direction. Okay. So this is how actually you will find out, okay, how to reach all its 8 directions. Okay. Okay. So I can see few messages. So if you have any doubt, you can message in me in the chat box also. So I will get to understand that what you are not understanding. So I will explain that again. Okay. Now you can see here. Now let's move to the next part. We will know how to reach the all its direction by this operation. So for we have to store this in any array, and after that what we are going to do, we will have to get each one by one and see that if in that direction any tree is present, and if the tree is present, if tree is present in that direction, then what you should do, you should have to consider that that tree should not be already been burned. Okay, that tree is not already been burned. I have explained to you there that how you will incur that condition. For this tree, we will have this tree also adjacent and this tree also adjacent, but we will only go there and only. Okay, we will not go in this direction. Okay, are you getting it? Okay, sir, please explain the negative index. Okay, the negative index will be what I am telling you. You can see there I have already gotten this negative index. So when you are at 1 comma 1 and this is the direction, you can say this direction as this is north, this is west, So if you want to move to the direction northwest, okay, and the northwest direction have actually index 0, 0. So from 1, 1, how you will reach 0, 0? So you have to subtract one from the row and one from the column, and from how you can actually get the index negative indexing. I think this has been clear with you. Please message me if this is clear. Okay. Now, this is how we get all its direction. Just I am using the practical thing. I am not saying anything to you for remember. Okay, you do not have to remember anything, because nowadays what actually happens, teacher will just show you the algorithm and you will remember that algorithm. Okay, this is being done by BFS and this is done by DFS. So you remember the approach. Okay, something is being changed, then you will not able to solve that. Okay, so I am just telling you how actually you will get that. You do not have to remember anything. I am getting all the 8 directions just by looking at this diagram. Okay, I do not have to remember the indexing of the diagram only by. Okay, whichever direction I have to reach, I have to go and look at how actually it is being getting, and that's how I am actually getting that direction sense. Okay, from my. Now again I am using the common sense. So if there is any tree in that direction, then we have to do what? We have to see that it is not burnt yet. If this is not burned yet, that means it is not been reached by anyone. So I have to reach it because it is in my adjacent and it is not burned yet. You can see from this example, I am at that tree, I am at this tree. Let me zoom it out. I am at this tree. I have 2 trees at my common, this tree and this tree. But since this tree is already been burned, because I am only burnt by this tree, so I will do what? I will only burn this tree because this is not burnt yet and it is in adjacent direction to me. So it is my duty. It is my duty as a tree to burn my adjacent tree according to the problem. Okay. So when we reach to any tree, we have to see if this tree is not burnt yet, and if it is not burnt yet, so we will burn it and add that to my queue. Okay. Simply add that to my queue. So here I have initially added a queue. In BFS we have added a queue. So queue will actually contains what? Queue will contains actually the index of the tree which is burned. So that we will go to the queue again after operation of this tree will over. Then we will go to the next tree which is present in the queue, which is actually burning. So that we will go to all of its 8 direction, adjacent direction of that queue. Okay, of that tree only. Are you getting this? Of that tree only, so that you will get to burn all its adjacent trees. Okay, so I hope you are getting this problem very good. Now let me go and write the code with you guys, and let me explain the code one by one. Okay, so what I am doing, I am writing the code in C++ because I have a C++ compiler ready with myself. And not worry, if you are writing the code in Java or any language, we have a code. I will show and explain you that code again. Okay, but for now, let me just solve that. Let me just solve that approach. So let me use my compiler. Okay, so this is the compiler that I am using. Actually a C++ compiler. If anyone is familiar with C++, then they can understand this. Otherwise, I am telling you the Java code. Okay. Let's wait a second. You can watch that Java code one by one. Okay. So what first I will do? I will first have to include the header file. Okay. And after that, okay, this is the header file complete for the C++. Okay, if anyone is familiar with C++, then that thing you have to do. If you are coding in Java, then you have to include the Java packages, let's say java.util or something like that. Okay, this is the package includes in something like this. Now, we have to write the main function by ourselves only, and that thing you have to do in the TCS actual examination also. You have to prepare with thing only, because if you are coding in lead code or GFG, then you are not familiar with writing the whole code by yourself only. In lead code and GFG, what actually happens? You have been performed with the automatically function, and there the parameter is being passed only. You have to just write the logic there on. But in the TCS, you have to write the code from the scratch. So you should have the practice of it, writing the code I recommend you to write the code by yourself only whenever you are coding and preparing for TCS examination. Okay. Now you can see from here. So what I am doing, so here the question will suggest, okay, here the question will suggest, you can see the input will be like, the first in line of the input will be and. So m and n will be the first two input, which will actually represent the rows and columns. Now we have to take the input at also. So first let me take it as input m and n. Okay, let me just increment it. Okay, I think now it is quite visible for you. Now you can see from here, int x comma y and the sim x and y. Okay, are you getting this? Now for int I equal to 0, now we have to do what? Sorry, we have taken the rows and columns as input. We have taken the coordinate of first tree which in the forest, which is to be burned initially. And now what we are going to do, we have to get the tree structure as an input. Okay, so tree have actually m rows and n columns. Okay, and let me first create a 2D matrix which will actually hold up that. Okay, which will actually hold up that. So what I am going to do, I am creating a 2D matrix. Let's say if I am creating a vector of int, okay, and let me name as matrix, and in the matrix has actually n rows, okay, m rows and n columns, okay, and n columns, and every row initially, let's say I filled every row and column with the 0. Okay, wait a minute, it will be actually not 0. What it would be, it is actually a character value, because there will be a character. So let me change it to char. Okay, and let me fill it with any char value. Okay, if I want to fill it with anything, let's say fill it with the a, nothing very much important to us. We can change it up when we are taking it as input. Okay, now let's take the forest as input. So int I equal to 0, I less than m will be my row first, I plus plus. Okay, I think you are aware of this, that how actually you take that matrix as input. Sorry, this will be z equal to 0, z less than n and z plus plus. Okay, now we have to take what? We have to take every index of this matrix which have m rows and n columns as our input. Okay, so matrix I and they will be taken as input. Okay, this is how the input portion is being done. We have taken everything as input that is being needed for us. Now input thing is done, we have done with this thing. Now we have to go and solve that up. Okay, solve. Now we have to focus on the solving approach. Now for solving, what we are going to do, okay, we are actually, let's say we are creating a variable name and answer, where actually we are storing our answer, and from here there we are calling a function. Let's say the function will be named as anything you can name. Let's say we are doing BFS portion, so we are just doing the writing BFS here on. So BFS, and in that BFS the parameter is passed as what? You have to consider the parameters that you are passing. So here first parameter we are passing the coordinate of the first tree that is being burning, but I have told you this is given in one index form and we are actually doing as 0 index form. That means we have to first subtract 1 from both x and y to get a 0th index form initially. So we are just, while we are passing, we are just decrementing -1 with both rows and column position of the tree which is being burned first. Okay, and now we have to pass the m comma n, which is the ordinal size of rows and column in that forest or matrix that we have taken. And after that we have to pass the matrix, okay, or the forest. We have named it as mat. Let me change its name to forest. Okay, that will be more understandable because we are creating a forest. Are you getting it? So we have created a forest. Instead of mat, let me pass the forest here. Okay, this is being done. Okay, now we have to deal with this BFS function that we have recently created. So now let's declare this BFS function and do our work thereon. Okay, so this BFS function will actually return integer type value because the value where it is storing is an integer. So that thing is being understandable to you. Okay, now in the BFS, the first parameter is actually x, the second parameter is actually y, the next parameter is eventually m, and the next parameter is n, and after that we have been a matrix of forest. Okay, so let me take, sorry, there is a character, let me take it as also input. Okay, forest. Okay, I think you are getting it. Yes, forest. So now we are into our now BFS function. So here on we have to write our BFS code. So while I am explaining you the BFS approach, I have told you what in the BFS the foremost important thing is what you have to create a queue where you will store the current index of the tree that is being burning recently. Okay, so the queue will be initially holding up what? Queue will be initially holding up what? So initially queue will be holding, let me first create a queue. And the structure of queue will be what? The structure of queue will be, I have explained you, okay, I have actually erased it. So queue, the structure will be what? If you look it as, so queue will hold actually 3 values. The 3 values will be what? First value will be x, that is the coordinate of x and y, that is the coordinates of the tree that is being burning. And the third value is actually the time at which this tree is burning, because while we are explaining you in this diagram, we are also considering the time. Whenever the tree is being burning, we have to consider the time eventually on. Okay, so this thing we have to consider. Okay, so actually there are 3 values present. Okay, and I have told you in the STL part, whenever you need in any data structure to store more than one value, then you will compress it in the form of pairs. Okay, so we will have to create a pair. Okay, and in the pair, inside a pair, so here you can see, if you see this structure, 3 values, so this is actually a pair, and inside the pair again there is a pair. So there is a pair inside a pair. Okay, you are getting it? Okay, so there is a pair, and inside that again there is a pair, and that pair will actually hold up value what? Integer. Okay, so this integer will be actually x and y. Okay, and after that there is again an integer which is inside the outer pair. Okay, which is actually a time. Okay, and again there is an integer, and that is being held up against the outer pair. And now we just have to write what? We just have to write it here as what? Let me write it as q. Okay, name it as a q. Are you getting it? Is this clear with you? Okay, now you can see here on. So we have created a queue. Now inside the queue, what we have to put up initially? So initially in this queue, we have the coordinate of x, coordinate of y, that is the first tree that is being burned, and the time will be as value 0 because it is the 0 time where the first tree is being burned. Okay, so q dot, okay, let me insert it in the queue. So while inserting the queue, we are using the push. Okay, so push is actually function through which we can insert something in our queue. So in the queue, we are inserting something in this way. Okay, so here inside a pair, there is again a pair which will be actually x and y, and after that it will actually a form of pair. You can see it as a mathematical values. Okay, will be 0. So here you can see the coordinate of x, first tree that with x and y is inserted as a pair. This is the smallest pair, and after that there is an outer pair where it is being paired. This pair is being paired with the big pair with the value as time, which is actually 0. Okay, I hope you are getting this. Now this is done. Now one more thing we have to consider, that is a visited visited array, visited array, which will actually hold up, the data that which tree is already been burned and which is yet to be burned. Okay, are you getting this? So for that we will have to create a visited array. So let me create a vector of vector, because the array will be again the 2D array, same size of the forest. So let me create and let me take it as a type of boolean. Okay, because boolean will hold up two values, either true or false. Okay, so that will be easier for us to manage, and this will be named as visited. Okay, visited, let me name it as visited array. And in this visited array, m will be the first column, m will be the rows, and n will be the columns, and this will be done in this way. Okay, and initially we haven't burned any tree yet, so we will have to mark every position at a false. Okay, and comma false. That means every position, every tree in that matrix will be initially not burned. False means it is not burned yet, true means it is being burned yet. But since we are at a position x comma y initially here on, and this tree is being burned at the 0 time, so we have to make sure to mark that position, that means x comma y, okay, x comma y as what? X comma y as false, but we do not have to do it here on. Okay, we will mark that up. So this position should not be marked up here on. So what we will do, why I am saying you this, because if we mark this at false, let me go inside. Okay, let's say visited of x comma y as true. So when we mark that position as true, that means that tree is now burned up, and that is the reality, because this coordinate position is now burned up. Now when we go, so let's go. What we have to do now, we have make that all thing up. One thing we have to make more, that is all the 8 directions. All these 8 directions we have learned about. Okay, after that we will search for the trees. Okay, that is to be burned. Now make the directions. Okay, so let me create an array which is, let's say, vector is actually a dynamically allocated array. If you are not aware with the C++, you can consider it same as the array list. Okay, if you are familiar with the Java, then you can consider the same topic as the array list. Okay, now let's consider it here. So it will be actually vector of, again the direction will be in the form of pairs only. So vector of pair of int comma int, and now here again you can see, name it as dir, directions. Okay, name it as directions. This array will be named the direction, so you will get to understand. Okay, that's why I'm taking it as name. Now let me take each direction one by one. So the first index will be what? You can say, let's say 0, 1. Let's say what 0, 1. The next position, we have to consider all the 8 direction. Okay, 0, 1, 0, -1. Consider it. Okay. Now the next direction will be what? 1, 0. Okay, no worries. Next direction will be what? Let me consider -1, 0. That is again fine. And ongoing with that, the next direction will be what? 1, 1. Then the next direction will be -1, -1, and so on. The other direction will be what? You can answer it in comments. Okay, we have taken -1, 1, 1, and 0, 1, 0, -1, 1, 0, -1, 0. Okay, let me take others. 0, 1 will taken, 1, 0, 1, 1, -1, -1. -1, 0 is also been taken. 1, 2, 3, 4, 5, 6. Okay, we have taken till 6 directions. So let me remember other direction also. -1, 1, 1. Okay, can anyone suggest anything? Okay, I remembered. Sorry. Here again the combination will form -1, 1. Okay, and 1, -1. Okay, so these all are the 8 direction. Okay, that we have to consider here. Now we will make the direction. Now we will go inside the queue. Okay, in the DFS, we will go inside the queue till our queue will not be empty. When our queue will be empty, that means there are no tree in the queue that is being burning right now. That means all the trees being burned. Okay, because the question will say that this question will consider that in all possible condition, all the trees should be burned. Okay, every time the tree will be burned. Okay, so let's go inside the quickly inside the queue, right? While queue not empty. Okay, while queue is not empty, we will do what? We will go inside the queue, and at a time, however present element are present in the queue, whatever the size of the element queue will consider, that all trees will be burned together at the same time. What I am telling you, if you see this structure, so this tree will go and took these two trees, and these two trees will burn together at the same time. That means at the same time. Okay, so we have to take these two trees together at the same time positions. Okay, are you getting it? Okay, so we will do what? We will consider the size here. Let's say size will be sz equal to q dot size. Okay, it will get me the size of the queue. And now this is being done. When this is being done, okay, let me see if some chat is coming or not. Okay, if this is being done, so we are moving where? We are going forward, and right till this size will not be empty. We are moving in this size of the queue, and every time we are doing what? Okay, let me see some chats are coming or not. Yes. Okay, so what I am saying you, okay, we are going in this size, and every time we are doing, we have to create a pair. Okay, pair of, or we can say int xz. Xz will be what? You can say the position, first position, the row of the tree that is currently burning. And how we will get that? We will simply go for the queue, and in the queue we will go to front. Okay, to get the front element in the queue, and thereon we will go to the first, and in that first also we are going to the first. What I am telling you, you can say we have explained this all in the NQT course. Okay, in this queue, if we consider this pair form, okay, this is simple. Okay, this simple concept. Here inside a pair, again a pair. So to reach this value, we will go to q dot front, and in that front, okay, in that front there are two values. So for getting the first value, we will do q dot front dot first, and after that, to getting it again the first value. In the first we are getting the first, we have to write q dot first dot first. It's actually a nested loop. Okay, you can consider it as actually a nested loops. Okay, nested loop structure you can consider it as. Okay, the same thing is being doing on here. Okay, I think you are getting it. So now let me do it. So this is actually xz. Now we can consider yz as the position, q dot front, and in that front the row position is in the first, the second position is the row. Okay, and now if I have to consider the time, that in which time actually it is being burning, that is being stored where? Q dot front. Okay, q dot front, and in that front the second value will be what? The actually the time at which the tree is burning. So we will get that value. Okay, and now since we have to return any answers, we have to create an max. You can create as an answer which is actually initially 0, and whenever we get any new time, we have to consider that this time is actually greater than our answer or not. We have to check max of answer of time to get the new time for us. Okay, now you have to check here on. This is being done. Now this comparison is being done. Now this tree is burning, that is for sure. Now we have to check all its 8 directions. So how we will get all its 8 direction? So here the direction position is being written. So we will have to iterate over this direction array. Okay, so we will use an auto iterator. Okay, so we have to write simply auto address of direction, okay, we will create an iterator name as dir, let's say, and that will be iterating over the array which is named as directions, okay. And we are doing what? Every time we are going on in this, and we have to get a int new coordinate, new of x, which is actually the new coordinate of x, which we are going from this array to its adjacent position. This adjacent has a new coordinate of x, and how we will get? We have to do what? X plus the direction, that means the x direction, we have to do the arithmetic addition thereon, okay. So dir, because here again it is in the form of pair, so it is again dir dot first, and again the next value we will get new of y, which is again what? You can say y plus dir dot second, okay. Are you getting it? Is this clear with you? Okay, that's fine. So now we got a new coordinate adjacent to my current tree position, but we have to check if there is any tree present or not. Because this is the flow code. If there is tree present or not, or if there is a tree present, then we have to check that if it is burned yet or not. So how it is being done? So it is being done by using two positions, okay. We have to check that if actually the position is actually valid or not. First we have to check the position, if this is valid or not. So how actually we will check? We will call a new function, let's say is valid, okay. That means this index is actually in the range of the matrix or not. We will part that this new x, new x and new y, okay, and then we will pass m comma n, okay. If this is valid, okay, if this is valid, let me call this function. So this function is actually a Boolean function. Bool is valid, and thereon we are passing two parameters initially x comma y, which is the current index, and then m comma int m. And there what we are doing? We are returning true or false. That means the index is lie in between our matrix range or not. And how we will get that? We will simply get that using this pattern. Okay, you can see here on. So x should be get less than equal to 0. Okay. If the index of row will be negative, then that will be not valid. Or the row will be greater than or equal to, okay, the m value. That means the row. Then again it is not valid. Okay. Both the condition whenever occurs, a row will be not valid. Okay. Yes, I can see few answers are coming. Please write the code in Java. No worries, I will be showing you the Java code as well. And few are saying, yes, this is a hard question. Yes, I know. But the package that TCS is offering to you to solve the coding problem is actually very good. You will get either 7 LPA package or 9 LPA package. That is actually very good in any service-based companies. Okay, so you have to consider that. And actually, there are 3 problems been asked to you. And the one problem is easy that you can solve. Okay, we have hundreds of that problems in our TCS NQT course, and there we are taking the live classes more and more. Okay, but here in this class, I have to tell you that this kind of question is also been asked. You have to prepare for this kind of question also. If let's say I am showing you some basic course of binary search or something like that, and you will be happy that yes, this code is understandable to me, I can solve this easily. But you will not get that kind of code in your examination only. Okay, you have to face the reality here on. So you have to well prepared. If you want 9 LPA package, if anyone wants for TCS Ninja, just TCS Digital, you can solve one problem, and that kind of problem is already been discussed. This is the second live class, coding class. You can watch that up also, or you can join that TCS NQT courses also. There are also 50 plus questions has been available. They are only solved for TCS NQT portion. But since I am solving you here one question with you guys, so I want to discuss with you a very good question. Okay, that will be actually helpful for you. Is this clear with all? Now we are actually end part of this video. Now this code is actually ending. Okay, so please wait till that. So you can see here, if this is valid, if this returns me true that yes, that index is valid, then we have to check that if that index which is valid, if there is any tree present or not. So how we will get that? So actually tree will be represented as T. Anyone asking what is T and W? So tree, I have already told in this video that T will represent in the forest as tree. Okay, sorry, it is new X, not X. okay, and new y. Okay, and if this is actually tree, okay, that is also fine. But there are one more condition. That condition says, that condition will say that this tree will not be burnt yet, and that is being actually handled by this visited array that we have created initially. Okay, and if we have to check if visited of that new position, okay, new x and new y is actually false or not. If it is false, then it is fine. Okay, we can go. It is false means yes, it is not visited yet. So we can visit that up. And how we can actually visit it? So we will go and first mark it as burn tree. Now because it is now burning, I have connected with it. I am going to burn it right now. Okay. So I am going to burn it. So how actually I burn it? Mark it as true. Just marking it as true, I am considering it as burn tree. So if again this index will occur somewhere, okay, in respect to some other tree directions, so we will not confuse thereon, okay, because this tree is already been burned now. And now we will have to push this direction in my queue, because queue will hold all the trees which is being burned by some tree to its adjacent directions. Okay, how we will do that? Simply insert in the form of pair. Okay, firstly the indexes, and on accumulated with that pair, the next value in the upper side of the pair, in the next pair, in the second pair will be the time. And now the time will be what? So initially this time will be stored here. But you can see in this example, whenever we are reaching any new tree adjacent to it, which is not burned yet, so from 0 we will go to 1, from 1 we will go to 2, from 2 we will go to 3. So that means we will have to increase our time with 1. Okay, so time will actually increase by, time will actually increase by 1. Okay, so this is all. Okay, now actually this is being inserted. Now again the queue will run. Okay, queue dot push, anything problem here? Okay, so this is being done. This is being done here on. Okay, are you getting it? Okay, small bracket is missing. Okay, I think you are getting it. Okay, is this clear with you? Now, I think this code is clear. Now, after coming out of this queue, when all the queue size will be done, okay, or when queue will be empty eventually, then we will have to do what? We just have to return the answer, which is actually the maximum value. And it will got the answer here in this variable, and simply have to print this answer here. Okay, and line. Okay, let me run this code with you guys. Okay, something is missing. Let me check what is the problem here. Redirection of int as int answer in the 48. Okay, let's check the 48 line. Okay, what is this? Not int answer, just return answer. Okay, since it is a function which is returning integer type value, yes, where the answer is coming. Okay, if I am taking everything correct, let me see. M and forest J, yes, this is fine. X comma 1 minus y comma 1, everything is good, correct. Okay, this is correct, this is correct. Let me run this. Okay, why it is. Okay, so I'm getting it. Okay, yes. Okay, one thing I have done wrong. I have not pop out that position. Okay, so queue will not be empty and this code will run forever. Okay, queue dot pop I have to done. Whenever I inserted any value, so I have to pop out that value from the queue also. Okay, so I'm getting my value. Okay, so value I am getting as 0. Why I am getting the value as 0? Let me check it out once. Okay, I think I have to not do that. And now let's on this. Again, it is coming as 0. So I think something is missing out here. I'm missing out on something. Mhm. Yes, yes, this is correct. This is good. This is good. Okay. Okay, okay, okay. Okay, this is not. I have just, while talking to you, x should be greater than or equal to 0 and x should be in less than m to be in the range of to return it as true. Okay. Y is greater than equal to 0 and y should be in less than m. Okay. Now I hope everything will run fine. Let's hope. Okay. I've got my answer. Okay. So here you can see, let me show you the Java code again. Okay. For the problem. Let me show you the Java code where I have written the Java code. You can see the same Java code is being available here. Let me zoom out to you. If please answer guys, if this Java code is being available to you guys. Yes, 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 I got it. I have changed the is valid function and it is getting me the correct answer. Now you can say, everyone can say, are you seeing my Java code? If anyone wants to see my Java code here on. Are you getting this? Is this clear with you? Now, if this is clear, so I am giving you one task, okay, so that you can do by yourself. If this is available, and comment down in the comment box, okay. So that task is, you can see here, you can see the task is what? If instead of this, a condition will say, here the condition will say you have to assume that tree will always burn out. But I am giving you one question instead of this, that let's assume one condition that if all tree will not burn out, if there any case, if all tree will not burn out, then return -1. Are you getting it? I am giving you one question, just improvising this question with you. Okay. Okay, Soham, I think you are with me from the start. Please comment down, because I have explained this whole logic with you guys. Okay, from the initial problem itself. Okay, you can watch this video in rewind. Okay, I've explained this whole logic from an hour only. Okay, from 1 hour I am explaining all the logics. Okay, let me explain with you again. Okay, let me zoom it out with you. Okay. Okay, so you can see what I have done. The logic is just simple. I have just called a BFS function from here. Okay, and in that BFS function, we have created a queue which will store actually the position of the tree which is being burning along with its time. Okay, so that's why we have created this structure of pair. And then we have created one more visited array which will actually store that which tree is being burned and which is not. Okay, I've explained you this already, that why I'm taking this visited array. And then we have marking this visited array true whenever some tree is being burned and false if it is not burned yet. And then we have created one direction array, because any tree which is currently burning will burn all its 8 direction adjacent trees. Okay, so that if there any tree present, okay, so we have to create all its adjacent direction. We have explained you this already. Now we move to this while loop, which is say while our queue is not empty, that means we will go in the while loop till all the trees not been burnt. Okay, we will not done with all the trees, and inside that we are moving to every tree direction, and here in the direction part we are moving to all its 8 directions, and we are checking the part if the new index that we are is valid or not. If it is valid, then the next portion comes that if there is tree or not. If there is a tree, then the portion comes that if that is visited or not, and if all will be prevailed, if the index is also valid, if there is at that index the tree is present, and if this is not visited, that means if it is considered to be false, then we will visit that. And how we will burn that up? We will visit that and mark as true. That means it is now been burned. And now we will push that new index in my queue with an incrementing of time. And after that, we will do what? We will move there, okay, burn that up, burn that queue up. Are you getting it? And then we will move till all our tree is not being burned, and after that we will simply return an answer. And answer will be what? The value maximum between our current answer and new time which we will get every time. Are you getting this? Okay, so you are checking. Check the visited vector. If tree is left, then return true. Okay, so you can say the visited. What you are saying, I'm not understanding, Mohit. Can you explain it again? Okay, thank you, so this logic is clear. Now, since this session is about to end, yes, I know I have taken a bit very good code. Okay, this is actually the hard problem which is being asked in 2023 TCS NQT examination. I have told you this question I have taken from there on. Okay, and yes, this is a good question. So you have to have very good knowledge, because in TCS you will have 90 minutes. Okay, and there you have to solve 3 problems. So first problem will be very much easy. You can solve it in 10 minutes only. Okay, if you have good practice. Now the second and third problem will be very good. Okay, so you have to solve 2 questions to make sure that you will call for either TCS Digital or Prime if you work, if you perform very good. Okay, so you have to solve 2 questions, and this kind of question you will get. Okay, so you have to have a very good understanding of programming to clear TCS, because TCS is offering you very good package in this. Okay, are you getting this? Okay, so now what I am saying you, let me show you this again, where it is. Okay, so one thing I will again recommend with you. Okay, so some internet connectivity problem, no worries. So you can go and check out this TCS NQT course once again. Okay, because there on everything will be covered. You can see many teachers. Let me show you that teachers today also. You can see the multiple live classes being taken there on also. Okay, you can see the success story of TCS through TCS, and many more companies. Our student will getting placed there. You can see many success stories there on, and we are performing daily live classes in YouTube also for you guys for the free purposes. So you will get benefited from this only. Okay, and if you want to benefit more, okay, if you want some personal attention, then you can join this TCS NQT course. You can see the weekly schedule is being shared with you also, and then you can say this course again. You can say some success stories selected in Deloitte and something like that. Okay, multiple teachers is coming out to solve this problem with you guys. Let's say I am taking coding, and 2 teachers are taking coding with you guys. The aptitude and reasoning part is being solved already by Pratik sir, which is a very good teacher. You already know that. Okay, so this thing you will get if you join the TCS NQT course. Okay, and I think the time is actually quite large. If you have any doubt, you can comment down also. We will try to answer your doubts there on. And one more thing I would like to ask with you, if you like this video, please like, so that we will get the motivation to create more such content like this, because this content, to creating such content will take lot of our energy. This course, I think this video is already been 1.5 hours almost. Okay, so I'm stopping this video here. Okay, so we will meeting some other time with this concepts. Okay, we are going to discuss. If you have any doubt in that problem, we are going to discuss this problem again in the next class which I am taking. I have also given you one assignment to solve. You can comment down a solution of that assignment also in the comment box, so that others get benefited with this also. Okay, so thank you all for this approach. Okay, we are going to have this video stop here. Okay, we are meeting in some other videos. Thank you.